In this video, we're going to continue our discussion on PLC programming. So for this video, we will talk about the PLC control with the reversing motor starter. So on the screen, if you look at on the picture, that shows a FVR that represents full voltage reversing motor starter. Right. So if you watch my previous video, you know we talk about the 3-wire control and the conveyor control. Right. In those cases, we only use one motor starter. Right. So we turn on and turn off to control the motion of the motor, but that is only on one direction only. Right. So in that case, mostly you will see that in the industry will use something like this. This is on one side. So this is the contactor, or called motor starter. There are different names. And then over here there's the overload control on here. So in this type of device, you only turn on and or turn off the motor. You only run that in one direction only. But in some case, right, we're gonna need to control the motor in both directions, forward and reverse. In that situation, we will combine both two contactors. You can see here, lots of people call that contactors. They are two identical devices, just put together side by side, and then they share the same overload to control the motor. So in this way, you can control motor in both directions. So when you energize one contactor, you turning the motor in, for example, clockwise rotation. And when you stop this and turn on this, then the motor will run the opposite direction, the counterclock or reverse direction. Right. So that's the basic concept of the motor starter. So in this type of motor starter, we basically use a you can see here the power connector to combine both. So you have one on the top, and then you have another one at the bottom. So in a moment, on next slide, I'm going to show you the details. So in this way, we have two contactors work together. But the very, very important thing with this type of device control is that you cannot energize both in the same time. You cannot turn on both directions, right? So if you do that, that's gonna have a disastrous. All right. So let's look at the next slide. I'm gonna explain that what's behind that. All right. So let's go to next one. So this next slide is just showing you the details on these two power connectors. All right. So these two power connectors on top and the bottom. As you can see that with the markers on the tracing, you can see that's 3-phase motor, right? 1, 2, 3. So that's on the top. At the bottom, as you can see here, basically they use the jumper to swap the phase 1 and phase 3. So that means when the forward energize, phase 1 go to phase 1, phase 2 goes to phase 2, and 3 goes to 3, the normal order, right? But when you try to go reverse, you don't connect this one. When you connect this one, so the phase 1 and phase 3, you can see here phase 1 connect to phase 3 and phase 3 connect to phase 1. So that means those two phases of this power supply will be short together if you energize both in the same time. So that's why this is very important for this type of device. You cannot energize both directions in the same time. Otherwise, you will see the power being short together, and the explosion and the fire and the damage of your device. Right. So, in order to demonstrate the operation of this type of control, I use a garage door to represent the result. Right, so it's just like the at our home, right? So we have every home has a garage door and use a motor to control the up and down, right, both direction, right? So but this one is a fancy one, right? It's controlled by PLC. So let's look at the logic. So right now you can see the door is stopped, and we have a indicator called ajar. Ajar, that means the door is somewhere in the middle, right? So for example, maybe just the door maybe is halfway open, halfway closed, in the middle, right? So in the upper position we have a top sensor. At the bottom we have bottom sensor to indicate where's the location of the door, right? For example, if that's a flag or sensor detect to check where is the door. Right now it's ajar, that means somewhere in the middle, and door is also stopped down here. So if I press up button, so when I press up button, motor up, you can see here I can only use this to represent the output. So motor up is energized. So that means one side of the starter is being energized. Alright, so you can see here the sensor state, I can only use the button to toggle it to simulate. So imagine, alright, the door will go moving up. When door moving up will trip this sensor. Right now it's an off state, but when the door is fully on the top, this sensor will turn on. So I'm going to click on it, change it to on. So when the sensor is on, you can see the door automatic stopped, and then the indicator light change from the ajar to open. So that's where the door is at right now. And if I press the down PB, when I press down PB, and then you can see motor is moving down now. That means the opposite direction, the other half of the motor starter being energized. Right? Remember, we cannot have both energized in the same time. So when when the down energized, the sensor will be deactive because the door is moving, right? It's going down here. So that sensor will turn off. I'm going to simulate that again. When that sensor turn off, the indicator shows, okay, door is in the middle now, somewhere in the middle, right, ajar. When the door finally reach to the bottom, so I'm going to toggle this one, bottom sensor going to turn on, and then you will see the door stop show up again. So neither the half of the motor starter will be energized at this moment, right? Both de-energized. And then in the same time, because the bottom sensor is on, the closed indicator light is energized, right? So we also have a stop button, right? So if you somewhere in the middle, if you want to stop, so like right now, if we want energize the up, it's moving up, right? And bottom sensor become off, you will see a jar, right? If you anytime when you press stop, the motor should stop. Right? So that's basic control with the this type of the FVR, right? Reversing motor starter. So those are the background and the demo. So now let's look at how do we design that, right? So like the video I showed you before, all right? So we want to analyze the input output first, right? So if let me drag out here, right? So over here, I'll just use a simple chart to represent the analyze process. So first, we want to identify the PLC input and also output. Right? As you can see here, I use this box to represent PLC. And then on one side, we have all the input devices. So from what I described to you, So you should be able to figure out, right? So we have bottom sensor, right? So that correspond to this. Sorry, let me clear out. So that's so bottom sensor that will correspond to this, and down button, that's a push button, right? That's this one, and top sensor, that's the other one on here. From the demo, you saw that, and up button is the other operator button. Also, stop button is this. So stop button, I also use normally open type, right? Not normally close. So all the buttons you can see here are normally open. So I talk about that on different video. You can check on that, right? Same type for the sensors. We just assume the normally open type on this demo. Of course, you can have a different type, right? But that's not the concern of this video now. So that's the input we have on here. From what I described with the on the HMI, you know that we have indicator lights, right? So those are the indicator lights as output. So we have ajar, closed, and fall light and open light. So I didn't demonstrate the fault. The fault basically represents if you have some sensor with the sensor problem. So in the normal situation, you shouldn't have both sensor turn on. But when you have both turn on, maybe this one, so you will see here, right? So you will see an indicator to tell you the both sensors shouldn't be on. That's impossible, right? There must be something wrong. So that's why we have a fall indicator, right? So that's the fall indicators. And after that, we have this is one and this is the other one. I just talk about the motor starter, right? So one is down, the other one is up, two different directions, right? So that's the first step. So once we have the input output analyzed, we will focus on the output. And for each of the output, we have to find the combinations or truth table for those conditions become true. So in this situation, I will first focus on the easy ones. So we will focus on these three lights and also the open lights. They are 4 indicator lights. So basically for those 4 lights, right? So from what I described, right? So that's totally decided by the status of the bottom sensor and the top sensor. So that's the input to control the output, right? So in the middle, so you can see here, right? In the middle is just the PLC ladder logic running round and round, right? So running on there. So that's what we put into the instruction in the PLC. So at this chart, as you can see here, we first analyze the output on the 4 different lights. So we have 4 of them listed over here, and those 4 lights depend on the state of the 2 sensors. So both of them we use normally open type to be simplified, right? And then remember that we talk about if we want to decide the instruction, we have to choose that based on the tag value, right? So if you look at the first output, open light, when the open light turn on, right? So that we illustrate that when the open light turn on, so there must be the door activate on the top sensor but not at the bottom sensor. So as you can see here, the open light is on right now, and the state for the sensor, this is on, this is off. So that means the top sensor will be activated. When the normally open sensor being activated, you will see tag value 1 in the PLC, and that in turn decide to use the exam on instruction in order to get logic true. And in the same time, you will see this bottom sensor, right? Bottom sensor is here, that shouldn't be energized, right? And that's a normally open type with the value 0. That will determine we should use exam off instruction. And if you look at doing the same way, right? So when the close light turn on, the top sensor should be deactivated. That's why it's 0, right? And the bottom sensor energize. That's 1. And for the ajar, that means neither of them is being energized. So both will be 0, exam off, 0, exam off. And the totally opposite will be the fault light. If both sensors energize, we know something going wrong, right? So that's why both become 1 matched into the exam on, right? So that's why we have these 4 simple output figure out first, right? So let's look at the logic. All right, let me open the logic. So okay, look at here. All right, after that we directly map in the design from this row into this row, right? In order to energize the output light OTE, we have to use exam on top sensor and followed by exam off bottom sensor. Okay, so the second row, this one will go into here, right, with the close light as output and exam off the top sensor, exam on bottom sensor, right? Same thing for the other 2 rounds. So that's the 4 rounds to control the 4 different lights. All right, so let me clear out. So again, let's look at the demo on the HMI side. All right, so let me see here. Yeah, so we have this right now. Currently open light is on. That's why you can see on this side open light is on, because top sensor is on. And if we have top sensor off, both sensor off, then you can see a jar light on the logic. And same thing here, right? On HMI, that's the result. If that's a light, you will see the light bulb turn on, right? So if bottom sensor turn on, then the close light turn on. So that's matched here. And if both sensor on, and then you will see the fault turn on. So that's the first part, fairly easy one to decide to control the full indicator lights. All right. So the next part, we're gonna design the logic for the motor starter. So to do that, I just want you to go back a little bit. Before, if you watch the previous video, we have a video talk about the pneumatic valve, full 3-way, double solenoid, center close. So if you remember that, that's the similar situation. We have 2 output on each side of the valve, but we cannot energize both solenoid in the same time. So that's basically briefly review from the previous one. So this is one side, right, Y1, and then that's the other side, and center close. So on that video, I explained all the details why we need this design this. There's a very important concept involved called interlock. In that situation, so if you handling with the pneumatic or hydraulic valve, if you didn't pay attention, you energize both solenoid in the same time, it's not good, but not too bad, because you worst case you damage the valve, right? So it's not good for the valve itself. But in the motor control, if you energize both sides in the same time, that's much more damage will be done, right? So that's why we will borrow what we designed on the full 3 valve and back into the garage door control. Right, so that's, let me go back to there, garage door. Okay, so I'll just rearrange on that. So if you look at on this side, right, so this is what we designed back then for pneumatic valve. And then if you look at on the right hand side, I just want you to see the similarity between these two. So that's why I will not explain all the details with this part. So you can see here that's directly mapped into here. That's one side. And also this one, this portion is also exactly as the mirror image of this design. Very, very similar, right? The only difference for now with garage door control, you can see that very differently. So it's that because we want energize motor up to automatic stop. Remember back then we don't have anything here to stop the solenoid automatically, but now we want to stop the door automatically. So that's why we add those sensors into the logic. So if you think about what we talked about so far, if you energize the motor up, when that is energized, the top sensor is not being energized. So that means the top sensor should be in the off situation. Tag value is 0. Right? When that become on, is closed, that will become logic false to automatically stop the motor up. So that's why it's identical, almost like the second stop button, right? This is the manual stop button, and this is the second automatic stop button. So exactly the same thing happened to the downside. So when you drive the motor down, you need to watch the bottom sensor. So when it's running, the bottom sensor should be tag value 0. So that's why it's exam off. When the tag value change to 1, that means bottom sensor being tripped. So that should change to logic false. So de-energize the motor down. Alright, I'm going to clear out all the drawings so we can this time. So let's look at the demo closely here. Okay, so right now either of them is energized. So if I press up, you can see motor up energized on the logic side, right? So when I release, because they seal in, right, it just keep going, right? And how do we stop? We can either press the stop button manually or the top sensor change the state. So right now the top sensor is off. When the top sensor being tripped, change to on, it should automatically stop. You can see here. That's exactly happened on here. Right? So now if you press down button, right, same thing. When you press down button, this energize. So let me toggle the top sensor. Right now it's in a jar. And same thing, if we toggle the bottom sensor, that should automatically stop the motor down. Alright, so that's what happened on here. Okay, so the next video I'm going to talk about how to add new features on the existing design, and also by talking about that, I introduce a new instruction, large and large. Alright, see you then.